So this video is for network models. It is a topic on a few A-level business specifications. I'm going to be focusing on AQA, which is part of 3.10.3. So what is a network model? Simply, all a network model is, it's a visual diagram that represents the sequence and dependence of tasks in a project. So it's a project management tool. All right, so it helps, and this is crucial, it helps to identify the critical path, and we're going to be looking at what the critical path means later on in this video. So as part of this visual, we have a node, and within this node we have a node number. So this node number is 2. So that tells us that there has been a previous node, and that node number would have been 1. And it just pretty much tells us like a kind of a milestone within the project, so kind of like a time stage. In other words, between 1 and 2, there have been some activities that have taken place and been completed. It tells us the earliest start time. So the earliest start time it's just simply what it says. It means that at that point, let's say it's 2 weeks, that is the earliest you can start the next activity. And the reason for that is, if it was, for example, 1 week, some of the previous activities haven't been completed. So when we're talking about like the 2 weeks in this example, it means all the previous activities that have been taking place. Maybe there's a couple of activities that were 1 week, and then there was another activity which was 2 weeks. That means that we have to start at the 2 weeks to make sure that that one's been completed. We know the others have been completed, but that one is the important one. That is the one that we're going to start on with first, but we also need to know the LFT. The LFT is the latest finishing time. So all that simply means, and what happens is we tend to work forwards with the EST and backwards with the LFT. And the reason for that is because it can tell us the latest time a task can finish without delaying the project. So I'm going to kind of explain why we work backwards as we go through the examples, and I think it will make a lot more sense as we're working through the example. Also, we've got the activity letter and we've got the duration of the activity. So the activity letter, just this example, is A, and the duration of the activity is 7. All right, so we need to know that to recognize what's going to be, I suppose, inputted in the node, and recognize what's going to be the earliest start time. And again, I'll show that within the example. So what we're going to do is we're going to look at this earliest start time, and we're going to work through a project, just filling in the EST to start off with. Okay, so here's our example. We've got 7 nodes. The first node is at the beginning of the project, and it's the first stage, the first milestone, and obviously there's been no activity, so that's going to be 0. We get to node 2, and what we've got is one activity, which is, let's say, 10 days, and that's A. So our earliest start time for 2 is just going to be simply 10. And what we've got is the third node, again easy, just one activity, which is 3 days. So the earliest start time of node 3 is going to be 13 days. And then what we've got is we've got 4 and 5 that go into 6 from C, E, and F, or we've got just D going into 6. Now all that simply means is that there's events that can pretty much be managed concurrently. So what I mean by that is they can be performed at the same time. So we can be carrying out or allocating resources towards D, whilst also allocating resources towards C, E, and F. Now E depends on C, F depends on E and C, but D doesn't depend on them. So what we're going to look at is, first of all, we're going to look at node 4. So what we can see is that we've got an activity duration of 5 days. So again, node 4 is going to be 18 days. Then we've got E of 12 days. So again, that's going to be 30 days. And then we've got F. Now, this is where it might become a little bit more complex. So which one do we look at? Do we look at D or do we look at F? So if we're looking at D, we just simply add the 30 days to the 13. If we were looking at F, we'd add the 8 days to the 38. Now, obviously, what we're going to do is we're going to pick D because that is going to be the highest number. Now, why do we pick the highest number? Because if we pick 38, then D wouldn't have been completed, so we can't start. So remember, the earliest start time is the start of the next sequence of events where every previous activity has already been completed. So that allows us then to start the next stage. So when we've started on 43 days, every single activity prior to that has been completed. And then, of course, we've got one more activity, which is G, 15 days, therefore 58. Now, then we're looking at it from the point of view that 7 is kind of the end of the project and the final stage of the project. So what we can start to do now is look at the latest finishing time. Now, if we've got a situation where 58 days is going to be the end of the project, then clearly that's also going to be the latest finishing time as well. So we've got 58 days, and then we just simply work backwards. So with the LFT, we work backwards, and that helps us to recognise the latest finishing time of that sequence without causing delay. So if we work backwards, 58 minus 15, we've got 43. 43 minus 8, we've got 35. Okay, now that's interesting because the early start time is 30 days, but the latest finishing time is 35 days. That means that we've got some flexibility in that node and it's not critical. Now, because it's not critical, it means that if there is a slight delay, for example, a day, 2 days, 3 days, 4 days, it's not going to cause any issues to node 6. That might give us an idea as to how we can allocate our resources, and it might help us to think, okay, well, should we be maybe allocating our resources towards activity D more than, for example, activity E or activity F? Because what it simply means is D is more critical, because if there's any delay with D, then it's going to delay the whole project. So again, as you'd expect, node 4 also has flexibility, and then when we get to C, we do have to take into account D as well. So, for example, I'm going to use activity D of 30 because if I finish that node 3 any later than 13 days, then D is not going to be completed on time for me to start node 6 on 43 days. So it's very, very important that I finish on those 13 days. So I don't take into account 5 because otherwise it would be at a later point and therefore D would be delayed. So then I go work backwards again, 3, take that off, so it's 10 days. And then, of course, you'll always expect that the latest finishing time of the very first node, which nothing has happened yet, should be 0. But now I've done my nodes and I've done my EST and my LFTs, I can start to work out the critical path. And remember, the critical path is the one that there can be no delay. If there's any delay, then it delays the whole project. So of course it's going to be A, because that's the only activity anyway. Then it's going to be B, then it's going to be D, then it's going to be G. So my critical path is A, B, D, and G. C, E, and F have flexibility, as you can see in the nodes. So here's another one. Why don't you have a go? So feel free to pause the video and see if you can work out the nodes from 1 to 8 and what the critical path is as well. So here are the answers. We've got the completion in, let's say, 18 weeks. What was the critical path? Well, it would be C, it would be F, it would be G, and it would be J. Now, I've circled nodes 2, 3, and 6. Now, the reasons for that, as I mentioned previously, is because of the flexibility. And there's something that you can calculate, and that is, it's known as the float time, or also slack for certain activities. So let's have a look at that now. So what we have is the float time or slack, where it has a formula, and this is on the formula sheet that you can download free public access from AQA, and it is the LFT minus the duration minus the EST. Now some students just say, well, why can't you just simply subtract the node difference? But sometimes you have different activities going into those nodes. So this is the official formula. So if we're looking at the float time for D, or the slack of D, what we'd do is we'd start with node 5, because node 5 would have the latest finishing time for that activity, which would be, as we can see, 11. So 11 days, let's say. We'd minus the activity, which is 6 days, and then we'd look at the earliest start time, which is 1 day, and it would give us a 4-day float time for activity D, and it just highlights the flexibility within that activity. So this is a multiple choice question from AQA, and to be honest, it's quite common in AQA, they're not going to ask you to draw a whole network model, but what they might ask you to do is change it based on a delay that's already taken place. So in this one, it says activity B is delayed by 6 days. I've also seen it before where it was in a 16 marker, and the 16 marker specifically asked you to look at or assess the consequences of a delay in a certain activity, and you had to then obviously recalculate it, work out if the critical path changed, work out the consequences if they missed the deadline that they had proposed. So in this one, it says, based on the network shown in figure 2, if activity B is delayed by 6 days, the duration of the critical path must be. So B, it was 2. No longer 2. Okay, it is now 8 days because it's been delayed by 6 days. So that's going to change pretty much all the nodes from that point on. So instead of the EST being 2 days now, it is going to be 8 days. Instead of the node 3 being 5 days, it's going to be 10 days. For example, with node 4, instead of it being 9 days, it is now going to be 15 days. And with node 5, instead of 13 days, it is going to be 18 days. And that, of course, changes the whole completion date to 22 days. It also does change the critical path as well. But the question is asking, okay, what does this mean for the duration of the critical path? It is now going to increase by 5 days. So why are network models important? Well, first of all, it helps you to identify the critical path. Why is the critical path important to identify? Because it helps you to, I suppose, prioritize certain activities, and it helps you to ensure that you manage them effectively. And that might be, as I've said before, the management and the allocation of resources. Now, just remember, it's a project management tool, so it's to do with planning, and planning helps you to prepare for such big projects. So it helps you to kind of visualize the project. It helps you to identify dependencies. It helps you to understand what can run concurrently. And that, of course, is going to improve your time management. It helps you, I suppose, assess risk. So it can be done for risk management. And it also helps you to start thinking about contingencies. So if, for example, an activity is delayed, well, what might that mean? What is the impact of this? What can we do? What plans can we have just in case? So, and obviously the nodes give you an indicator of the progress. So it's kind of almost like a progress tracker. So based on that, you can see obviously how important network models are.